Hi, everyone. This is Ray Phillips of Precision Driving Analytics. And, one thing I like about my job is that I'm always learning and came across this cool math channel that estimates basically tire loads. And it uses combined G's to do that. So it's not using shock pots or anything. So really anybody can use this formula. And so I was playing around with it, and one thing that I really got out of it is it really demonstrates how important trail braking is, because you can really see how the tire loads are changing across all four tires and how the driver is balancing the car. So just kind of want to share that with everybody. I'm going to share my screen here, and I'm using WinTax software for Ferrari Challenge cars. And here we go. All right, so what we're looking at is Indianapolis turn 7, and that's this corner right here. And I've zoomed in on it. So it's cars are coming down the back straight and they're turning left into this turn 7. So I'm gonna kind of get rid of this map a little bit here. So what we have on the screen is we have this time distance chart with speed, steering angle here, throttle position, the most important one being brake pressure. And then these four are the tire loads. So left front tire load, right front tire load, left rear and right rear. Actually, left rear and right rear here. And then lateral acceleration and longitudinal acceleration. And then on this side, we have steering, and then brake bars here, a gas pedal, understeer and oversteer that the car has, and then the tire load. So we have left front, left rear, and right rear. So the way this series of formula works, it's actually a formula for each tire, is that it makes the assumption that all the load is going to be zeroed out if you add it up all, across all four tires. So if you add these, you got 0.12 tire load on the left front, the car's going straight down the back straight now. And then right front, so minus 0.16, minus 0.12. So the loads are on the rear of the car, so rear tire, so 0.16 and 0.12 positive there. So adding all those up, that's 0. And the reason why it's a little bit different across the tires is because there's a tiny bit of steering input here. So we have two different drivers. We have a pro driver and an amateur driver, and the pro driver is blue and the amateur driver is red. So as we look at this, like I said, that the car's on the back straight now, so car's going straight. Everything's relatively equal, right? We've got full throttle, virtually no understeer or oversteer. There's a slight amount for the amateur driver because he's got a little bit more steering angle, but nothing to be concerned about. And the tire loads are relatively equal. So, so you can see the slope of these lines for the brake pressure. So the amateur driver gets to full brake pressure a little bit later. He actually brakes, gets off the throttle a little bit later as well. And at this point, both drivers are effectively at their peak brake pressure. So if we look at the tire loads, okay, now the front tires have gone up, to about 1.25 combined Gs, a little bit less on the right front. So there's a tad bit of steering input already. And you can see that more with the amateur driver because now he's got 9 degrees of steering input and a little bit, actually he's got a little bit less tire load on the right front, but things are moving around at this point here. So that doesn't really mean a whole lot. Brake PSI, you can see the pro driver's got a little bit more brake pressure. Neither one of them are on throttle, and still, effectively no understeer oversteer. So, so as we're coming up to the apex of the corner, at this point, the Pro Driver has already started releasing the brake pedal. And you can tell by the slope of the line that he's trailing off the brake pedal, okay? Tire loads are still about the same, hasn't really affected anything yet. But as he gets closer to the apex, you can see at this point, the Pro Driver has greatly reduced his brake pressure. He's down to 613 compared to the amateur driver's 1178. And now you can start seeing the tire loads changing. So you can see on the left front, now that tire load is almost to zero, whereas the amateur driver, he's at like 1.1 or something like that, somewhere around there. Whereas the right front tire load has stayed about the same, and left rear tire load has stayed about the same. But now the right rear tire load is starting to increase for the Pro Driver. So, that means that he is gently transferring the weight from the left front to the right rear, because it's a left-hand turn. And, basically this is how he's balancing the car. You've probably heard driver coaches and all talk about the balancing of the car. This is really what this is showing is, this is how you balance that car and transfer that weight, I'll call it gently, from one corner of the car to the other corner of the car. Since the left-hand turn, the right front is going to stay loaded up. And the left rear is going to continue to be unloaded. So as the drivers get closer to the apex, let's get down to the nitty-gritty here. So now both drivers have come off, and now things have evened up, okay? Come off the brake pedal, but look at the speed difference. It's 56 miles an hour for the Pro Driver and 43.3 for the amateur. So the Pro Driver, by balancing, that weight transfer better, was able to carry more speed into the corner. Not only that, but you can see at this point, backed it up a little bit, the amateur driver has a little bit more understeer than the Pro Driver. And in fact, at this point, the Pro Driver does a little bit of a correction, and you can see the difference in steering angle. So the Pro Driver has gotten the car to rotate more by keeping the weight, balanced between these four tires. And just by carrying more speed in, so he's on the limit of adhesion here. So, you can see that he's making some corrections, but coming out, they're basically about the same speed. Pro Driver's a little bit faster, 68.7 versus 65.4, but nevertheless, he's taking a lot of time off the clock there. And you can see now that the tire loads have evened out again, and the steering angles have pretty much evened out, and now they're both at full throttle. So I thought it was just pretty interesting how that shows, the balancing of the weight transfer. Just to show it here, I'm going to show the lines that they ended up driving as well. I got to find, there it is. So I'm going to zoom in on this. So now you can see the Pro Driver actually was able to drive a much tighter line than the amateur driver. And I don't know how much time he gained there, but I guarantee it was quite a bit, because he drove a shorter distance. Car was much more in control, just by doing that trail braking and balancing the car. So balancing the weight transfer. So anyway, I just thought that was kind of cool. Just thought I'd show everybody, and hopefully you enjoyed it. If you want the formulas, just shoot me a message and I'll get them over to you. Anyway, take care, guys. Bye.